Hello viewers, today our topic is polynomial. So what a polynomial is? A polynomial is an algebraic expression in a variable where exponents of the variable are whole numbers with finite number of terms. So this was the definition for a polynomial. Let's understand this definition. Polynomial is an algebraic expression. What is an algebraic expression? An expression having constants, variables, and algebraic operations. All these built up to an algebraic expression. So written here, this is an algebraic expression having constants, variable, and mathematical operations or algebraic operation. So this is an algebraic expression in a variable. What a variable is? So when the value is not fixed, value varies every time, that is known as a variable. So this is a polynomial in x variable. X is not fixed here. These are the constants 4, minus 1, 2, 74. These are the constants. X is the variable here, and plus minus this multiplication are the algebraic operations. Where exponents of the variable. So variable is x here. Exponents mean the powers. So here x cube, x square, x raised to power 1, and this is what basically x raised to power 0, which is equals to 1. So need not to write 74 multiplied with 1 is 74. So exponents of the variable means power of the variables are only whole numbers. So this 3, 2, this 1, this not or 0, these are from whole numbers only, and with finite number of terms. So a polynomial is having only finite number of terms. It has a limit. So these are the terms. It has 4 terms: first term, second term, third term, fourth term. So this polynomial, which is denoted by p of x, x is variable, p is the name of polynomial. So p of x is basically the notation for this polynomial. I have taken this is equals to 4x cube minus x square plus 2x plus 74. So here I am repeating this 4, this minus 1, this 2 and 74. These are what? Constants, and x is the variable. Here I have taken, somebody can take it as y, z, v, w. So all these are small alphabets. So this is a polynomial in variable x where exponents are clearly from the whole numbers and have only finite, that means 4 terms in this particular example. So this was the definition for the polynomial. Let's move to the next concept or more examples. So basically here the powers or the exponents are fixed to the definition of whole numbers. Rest of the terms, rest of the material, rest of the numbers are real numbers we are dealing with. So if I have taken this example, y cube minus root 2y plus 44c. Let's see whether this is satisfying all the conditions of the definition of a polynomial or not. Is this an algebraic expression? Yes, it is, because it is having constants, a variable, and this we are dealing with a single variable polynomial here. So variable y and finite number of terms, and let's see the exponents are from the whole numbers or not. 3 is a whole number, this 1 is a whole number, y naught is a whole number. I am writing here any number or say alphabet or anything raised to power 0 is always 1. You can note this down. Any number raised to power 0 is 1. So here y naught, y raised to power 0, actually this is also 1. So generally we don't write because value is 1. So 44 into 1 is 44. Need not to write. So this is clearly fitting into the definition of a polynomial. Yes, this is a polynomial in variable y. So I can name it as q of y. Q of y is the name for this polynomial because here variable is what? Y. Let's see another example. Say let's take r of u. So here I will write a polynomial in variable u. So u 44 minus 44 u raised to power 3 plus root 2 over 5. Let's check whether this is a polynomial or not. Yes, this is an algebraic expression in single variable u. Exponents are clearly from the whole numbers. Terms are finite here also. So these were three conditions for the polynomial, and yes, it is a polynomial. Fine. Now we are here talking about only a single variable polynomial. Let's go with this example. There are few terms related to the polynomial. First one is the variable. Second, the coefficients. Third, terms. Degree we will discuss later. So if I am talking about this polynomial, what is the variable for this polynomial is? You can easily identify now. This was q of y. So variable here is what? Y. This is a polynomial in y. So what are the coefficients? Here coefficients, first one is coefficient of y cube. So the constant related to the y cube is what? 1. So the coefficient of y cube is 1. Second, coefficient of y square. Y square is missing here. So clearly the coefficient of y square is what? 0, because 0 into y square will be 0. 0 into any number is always 0. Coefficient of y square is missing, so clearly it is 0. Third is coefficient of y, which is minus root 2, because we are dealing with the real numbers in this algebraic expression or in the definition of polynomial. Fourth is coefficient of y naught, or someone can write it as constant value of the polynomial. This is 44. So these were 4 coefficients in this polynomial. Next are the terms. What the terms are? This polynomial is having 3 terms. So first term is y cube. Second term is, along with the sign, minus 2y root 2y. Third term is 44. So the terms are here 3 finite. So this is a polynomial in variable y with these coefficients and with these 3 terms. So exponents here are, if I need to write the exponents, means powers. Powers are here what? 3, comma 1, comma not. All are from the whole numbers. So yes, it is a polynomial. So this was a new topic. Among these, coefficient and terms were also, these are the terms. Next is the constant polynomial. Let's see what a constant polynomial is. If I am writing only 44, 44 is a constant. So constant polynomial. If I have this polynomial, if I have written only 44 or 2 or minus root 2, so these are the examples of constant polynomial, because here say if I am taking variable y, so this is the coefficient for y raised to power 0. This is a constant polynomial. This is, say if I am taking variable x, x raised to power 0. And if I am taking z here, suppose z raised to power 0. All these are constants. So these are basically the constant polynomials. Next is the zero polynomial. When our constant is fixed to 0, when suppose this I have written 0, here constant is what? Fixed to 0. So this is our zero polynomial. This plays a very important role in higher standards. Zero polynomial is what? Only 0, and the constant values are called the constant polynomials. Next are the types of polynomials on the basis of the number of its terms. Types of polynomial on the basis of number of terms. How many terms a polynomial has, divides it into many names. So I am writing here. First is monomial. Mono means one, single. Mono means single. A polynomial having one term only. A polynomial having only one term is known as a monomial. Examples are minus 25x square, root 2y, 2 by 3, z raised to power 44. So these are the examples of monomial. Here terms are what? This is a polynomial with single term, single term, single term. Only we have to look at the number of terms. That's it. So if it is single, then it is a monomial. Next is binomials. So bi means two. Polynomial having two terms. Having two terms only. Then it is under the name of binomials. For example, 2x plus 4. So these are two terms. 2x raised to power 4 plus 1 by 4x. This is also an example of binomial. Or I can take y raised to power 30 plus 1. So these are two terms, two terms, two terms. So these three examples are of binomial having two terms only. Next is trinomials. Clear from the name, tri means three, having three terms only. I will just give you one example. Say if I am having r of u is equals to u raised to power 4 plus u square minus 24. This is u, not 4. Minus 24. So this is a polynomial having three terms. So this is a trinomial. Just look at the polynomial, count the terms. We can write which one it is. Now let's move to the degree of the polynomial. Degree of a polynomial. Degree of polynomial. So the highest power in the polynomial is called its degree. Example, if I have p of x is equals to x cube minus 4x plus 2 upon 3 x square plus root 2 x raised to power 4 plus 3. If this is an expression, first let's check whether this is a polynomial or not. First we will check, yes, this is an algebraic expression. Exponents are what? 3, 1, 2, 4, not. So these are whole numbers, and the finite terms. Terms are what? Finite. So this is a polynomial in variable x, yes. Now exponents are what? 3, 1, 2, 4. Need not to write, or you can write it as 0. So the maximum, these were the powers or exponents. Maximum power here is what? 4. So the degree of the polynomial is 4. Degree is the highest power. They can change the order in the question. Lowest powers are written, could be written in the front, or the highest in the last. So we need to check carefully while checking the degree. So the highest power in the polynomial is degree of the polynomial. Now let's see the types of polynomials on the basis of its degree. Types of polynomials on the basis of its degree. Types or names. These are just different names for the different degrees for a polynomial. Number 1 is linear polynomial. So a polynomial with degree 1, or unit degree. Examples are 2x. We have nothing to do with the number of terms, just the degree of the highest power must be 1. 3 by 2 y plus 33. This is here degree is what? This is a polynomial in y. Degree is 1. Or root 2 z. Degree is what? 1. So these were the examples for linear polynomial. Second is quadratic polynomial. So with degree 2. Examples we can take 3y square, 4y square plus 5, 2 by 3y square, or we can change the variable as well. U square, take 2 by 3u square plus 2u plus 7. So these are polynomials with the highest power, here 2, here 2, here 2. So these are the examples for quadratic polynomial. Next is cubic polynomial. Cube means 3. So with the degree 3. Examples we can take 6x cube minus x square plus 4x, or 4 minus 7x cube. So here in both the examples, maximum power is 3 here, 3 here. So generally, the linear polynomial can be written as ax plus b, where a should not be equals to 0 and a, b are constants. So x is the variable here. General notation for the linear. This is 1. Degree is 1. Ax plus b. A should not be equals to 0. Rest can be 0, but a should not be equals to 0 because this is the coefficient for x raised to power 1. Here, for quadratic, general is ax square plus bx plus c is the polynomial, where again a should not be equals to 0. Why? Because degree is, we are talking about quadratic, degree is 2, so a should not be equals to 0 and a, comma b, comma c are constants. General for the cubic is, I am taking y here, ay cube plus by square plus cy plus d, and a should not be equals to 0, rest b, c, d can be zeros, and a, comma b, comma c, comma d are constants. So these were the general polynomials, linear, quadratic and cubic, and these were the types of polynomials on the basis of its degree. Now we know the degree, we know the terms, we know the coefficients, and we can create the examples while giving definitions. We know the definition for polynomial, we know about the exponents and finite number of terms. Next is the general polynomial. How we can write general form of a polynomial with degree n. General polynomial. In variable I am taking x. Generally we take x in variable x of degree n. How to write? Of degree n. So if I am taking degree n, the coefficient of x raised to power n should not be equals to 0. Let me name this polynomial as px. So if it is a polynomial of degree n, then we can write the first variable x raised to power n, and I am taking a n for the coefficient of x raised to power n. Now we will take the next term. We will just minus 1 from the n and write the next term. Next we will just write minus 2 from the n and that will give us the third term. We will keep on going like this. To end this polynomial, keep on going, say here comes. So from the end I will write it as a2 x square a x, which means 1 1, and some constant, say a naught, x naught we can write, which is basically 1. So this is the journal polynomial in variable x of degree n. We must know how to write. This is the way we can write. So here constants are a1, a2, a3, so on, an minus 1, an. These are constants. Here a n should not be equals to 0 because degree is what? N. So a n cannot be 0. So this was the journal polynomial. Next is degree of a zero polynomial. Let's discuss degree of zero polynomial. Zero polynomial is what? Basically capital 0. 0 is what? Zero polynomial. We denote it by capital 0. So 0 into any number is always 0. So if we take 0 into x raised to power 3, 0 into y raised to power 55 or 155 or 355, any number. So this here degree for zero polynomial is not fixed. It can be any number and the numbers are infinite. So degree of zero polynomial is not defined actually. Degree, remember this point, degree of zero polynomial is undefined or not defined. Next, see the degree of a constant polynomial. Constant polynomial. What a constant polynomial is? Any constant creates constant polynomial. Say if I am taking 34 and I have to write degree of it. Degree of it is what? Say this is a polynomial in y. So 34 can be written as 34 into 1, which can be further written as, it is a polynomial in y. So y raised to power 0, because I have already written y, any number raised to power 0 is 1. So any variable raised to power 0 is also 1. So degree is what here? 0. So we can take any constant, multiply it with 1, nothing will change. Multiply it with any variable raised to power 0, nothing will change. So degree of a constant polynomial is always 0. Remember such points always. Keep these points in mind. These are very valuable from interview perspective. Let's take few examples and see whether these are polynomial or not. So if I have polynomial, so if I have this expression, say root t plus t root 2. Check whether if this is an algebraic expression. Yes, it is. It has finite number of terms. Yes, it's having finite 2 terms. Let's check the power. This is if I say this is a polynomial, so variable is what here? T. So it's t raised to power, this root means half, plus this root 2 is just a real number or constant t here. This is 1. So powers are from the whole numbers only. So 1 by 2 is not a whole number. This doesn't belong to whole number. So this contradicts the definition of polynomial. This is not a polynomial. So check the powers carefully. It should belong to the whole numbers only. So let's take another example. X raised to power 10 plus xy plus 2y plus 44. This is an algebraic expression, but this is involving two variables, x and y, and we are here talking about a polynomial in single variable. So this is not fitting in our definition or topic of today. Let's see another example. Y square plus root 2. We will check whether this is a polynomial or not. Yes, this is a polynomial. Let me write here y square plus 2. Let's check all the things we have studied. Yes, this is a polynomial in variable y. So let's write the coefficients. Coefficient of y square and constant or coefficient of y naught. Coefficient of y square is what? 1. Constant term is root 2. If I ask a coefficient of y cube, obviously y cube is not here in the polynomial, so it's 0. And coefficient of y is also 0 because these are missing. Let's see degree of the polynomial, degree of py. Degree, the highest power here is what? So 2, so degree is 2. Next terms, write the terms. Number of terms, 2 terms. What are the terms? Y square and root 2. These are the 2 terms. So if the degree is 2, it will be known as a quadratic polynomial. Quadratic polynomial. Check whether this is a linear, no, check whether this is linear, a monomial, binomial or trinomial. This polynomial is having 2 terms. Binomial, binomial, trinomial has to deal with the number of terms. So this is having 2 terms. 2 means binomial. So this is a binomial. So I hope you understand the general concepts of polynomial well. Hope you like the video. Hit like if you like the video. Subscribe to my channel for more. Thank you for watching. Have a good day.